Hello friends, welcome to my YouTube channel, Paul Mathematics Academy. In this video, we have two types of questions to solve. The first question says evaluate I of A equals integral running from minus infinity to infinity of cos ax over s squared plus 1. And the second question states that hence evaluate integral running from 0 to infinity of dx over s squared plus 1. Now you have exercise evaluate integral running from minus infinity to infinity of sine ax over s squared plus 1 dx. So that one is for you guys to try. Now I'll be using the Cauchy residue theorem, which is under the complex analysis. So using the complex analysis, I would like to consider, let me consider this. Consider integral of C. This C is a semicircle. Yeah, where C is the upper half of the semicircle. So this is called the contour integral. Now let's integral this contour integral of fz dz equals integral running from minus infinity to infinity of cos az over z squared plus 1 dz. So are you getting me now? So I have the contour integral of C of cos. Now don't forget that cos az is just e raised power of I az over z squared plus 1 dz, where C is the upper half of the semicircle gamma with the bounding diameters, and the bounding diameters are minus r comma r by Cauchy's residue theorem. So let's move on. So by Cauchy residue theorem. Now let's move on. So we have our integral fz dz equals this diameter, these two, running from these two diameters from minus r to r of fx dx plus the integral. So this one is the gamma, which is the semicircle, half of the semicircle of fz dz. Now how can we obtain our poles? The poles of fz are obtained by z squared plus 1 equals 0. So z is equal to plus or minus I. So we have to use the first value, which is plus I. Now where z equals plus I, and this plus I is called the positive iota, which is the complex number root of minus 1. So that's I. So now we have to find the residue. So residue of fz of I will now give us limit of z to I. of z minus I of fz. Now, what was our fz? Our fz is e raised power of I az over z squared plus 1. So my residue of fzi is now equal to limit of z to I of z minus I multiplied by e raised power of iaz over z squared plus 1. So let's use the L'Hopital method. Now differentiate the numerator and differentiate the denominator. So I have limit of z to I of z minus I multiplied by ia multiplied by e raised power of iaz plus e raised power of iaz over 2z. So let's apply our limit, which is I minus I 0 times everything here, that's 0. E raised power of iaz, that's e raised power of, now this is what I'm saying. So I have I minus I multiplied by ia multiplied by e raised power of ia multiplied by I, so z is I, plus e raised power of ia multiplied by I over 2I. So everything here is 0. So I have e raised power of I times I, that's minus 1. So that's minus a over 2I. Now let me recall this. Recall that integral of fz dz will give us 2 pi I of the residue of fzz. And since we know the residue, so I have 2 pi I multiplied by e raised power of minus a over 2I. I cancel I, 2 cancel 2. So I have pi e raised power of minus a, which is equal to pi over e raised power of a. Now, hence, we are told to evaluate integral running from 0 to infinity of dx over 1 plus s squared. Now, from this question, integral running from minus infinity to infinity of cos ax over s squared plus 1 dx. Now, I can substitute 0. If I substitute 0 here, so 0 times x, that's 0. So cos 0 is 1. So I have my question. So which is this. Now, and don't forget that integral of minus infinity to infinity of integral running from 0 to infinity of fz dz is equal to half of integral running from minus infinity to infinity of fz dz. So I can transform this integral into this form. So that will be 1 over 2 integral running from minus infinity to infinity of dx over s squared plus 1. Since we know this value, so that will be pi over e raised power of 0. So it's equal to 1 over 2 multiplied by pi, which is equal to pi over 2. So if you like this kind of video, please don't forget to subscribe to my channel, like my videos, share my videos to your friend who also like mathematics, and don't forget to do this exercise. So submit this exercise to my comment link. Thanks for watching, and you can submit the assignment to this number. This is my WhatsApp number, 07049 75 30 53. 749 75 30 53. And if you have any question, you can chat me up on this number so I can explain further. Thanks.